Okay, today we are starting a new unit, Unit 6, and it's going to cover rational functions, and we're going to learn all about them, graphing, and solving them algebraically. So our first lesson is talking about the short-run behavior of rational functions. So first off, I always like to make sure you understand what we're talking about. And if I'm talking about rational functions, I hope you can see the first 5 letters spell out the word ratio. So a rational function is going to be any function that is in the form of a ratio, P over Q, or if you prefer the letters A over B, like Claire. Um, then either way, you just got to think about it. It's a fraction. It's a fancy word for a fraction. So the first function that we're going to look at is f of x equals 3 over x, or 3 divided by x. That's our rational function. They want us to find the value of x where f of x is undefined. So this is one of the most important things about rational functions. What makes this thing undefined? Pause. You two think for a second. And I hope you came up with anytime your denominator is equal to 0. Okay? When the denominator is equal to 0, then our function is undefined because we cannot divide by 0. So what value of x will make this undefined? Well, that value is 0. Okay? So that would be the answer to the question. Sometimes we just write x cannot be 0. I'll take either one. You can just give me 0, or you can tell me x can't be 0. And now to state the domain, you're thinking along a number line, and you got this whole long number line, which I'm going to draw right here. Okay? And you know that we go from negative infinity to positive infinity, and we have every number except 0. I can't have 0. So how do I write that? I can't have this point right there. So I'm going to go from negative infinity to 0, and then I put a parentheses because that means I don't include the endpoint. And then we have the mathematical symbol for union, which is or 0 to positive infinity. So you can see that's your whole number line to this point, but doesn't include the point 0. Okay, so next, on your calculator, you're going to construct a table of values that shows uh, construct a table of values that shows the values of f of x as x approaches 0. So what we are doing, okay, is you're taking this value that's undefined and figuring out what happens when we are less than that number and what happens when we are bigger than that number. So pause for a second, go fill it in, make sure that you know how to use your calculator, and then come back and I'm going to have the numbers filled in. Okay, so hopefully you got those same numbers. What we were doing each time, and I probably should have said this before I paused it, but you're putting in negative 0.5, 3 divided by negative 0.5. So you're taking each of these numbers and plugging it into the calculator, and you should get that when you come out. If you don't, you need to email me, come see me, and let's figure out what's going on and make sure you know how to use your calculator. Okay, so look at this next question. Part B says, if x is less than 0, as x approaches 0, what does f of x appear to be approaching? Okay, so you're looking at your x values and you're saying, if I look at them this way, is my value getting closer to 0? Or if I'm going that way, is my number getting closer to 0? So sometimes people have trouble reading these charts, so I just want to talk about it for a second. If you think about the positive one and you graph 0.5, so if I have the number 1 is right here, and then this is going to be 0.5. So where is zero point 0.1 going to be? Well, if this is 1/2, then 0.1, which is 1/10, is going to be here. And then 1/100th is going to be here. And then we're going to get closer and closer. Or if I'm on the other side at negative 5, and I go to negative zero point 0.5, so that's a point. And then I go to negative zero point 0.1 and negative 0.01, which is 1/100th. So hopefully you can see from that, think about the number line of these x values. So when I go this way on my chart, these numbers are getting closer to 0. This number 0.5, 0.1, that's 1/2, 1/10, 1/100th, 1/1000th. Those numbers are getting closer to 0. So the other thing to keep in mind is these numbers that are on this side of 0, okay, we will talk about this a lot, are on the left side. So x less than the number is on the left, and x bigger than the number is on the right. So we say, where does f of x appear to be approaching? So what are these numbers getting closer and closer to? I hope that you can see that those numbers are getting really, really small. The numbers are small, but they're negative. I mean, the numbers are large, but there's a negative sign. So it's those are going closer to negative infinity, and these, on the other hand, are going closer to positive infinity. Okay, so next, find the x and y-intercepts of the graph of f of x. Okay, so if you did this in the last lesson, this should be really easy because it's a little bit easier to calculate them with these rational functions. But keep in mind, as we have talked about before, an x-intercept is when you make y equal to 0, and a y-intercept is when we make x equal to 0, because that's where they cross. I didn't put the x in there. Make x equal to 0. Okay, x-intercept, make y equal to 0, y-intercept, make x equal to 0. So y also, in case you forgot, f of x is the same thing as y. So if I set this equal to 0, then I'm going, well, I got a fraction that's equal to 0. So when is a fraction ever equal to 0? Clearly, I can't have 0 on the bottom. That's when it's undefined. So it's only going to be 0 if the numerator is equal to 0. So sometimes that's a little bit easier. You don't have to worry about the whole fraction. So if you make your numerator equal to 0, so in this case, if I go back and say, well, I'm going to set 3 equal to 0. Can 3 ever be 0? No, it cannot. So that means that I don't have an x-intercept. Never, ever, ever will it cross the x-axis. All right, how about the y-axis? For the y-intercept, I put in 0 for x. Well, x can't be 0 because that's where it's undefined. So in this particular problem, we have no intercepts. Okay, so now they want us to graph the points on the tables of values and the x and y intercepts on the coordinate plane. So as we just talked about, we don't have any x and y intercepts, and this is what I want you to do. We did have the point x equal to 0 was an important point and didn't have any intercepts. But if you look at just these first points, like negative 0.5, negative 6, and 0.5, positive 6. So if you graph those, um, we'll do this. 1, 2, 3, 4, 5, 6. And then at 1, 1, 2, 3, 4, 5, 6. For sketching, I really don't care if you put those points in there, but I want people to understand better. So this is negative 1, this is positive 1. At negative 0.5, I was at negative 6. And at 0.5, I was at positive 6. And so the reason that I am doing that is because, and then the other thing we said was on the left side of 0, as I got closer and closer to 0, my graph went to negative infinity. So that's enough to say that this is what my graph is doing. It's getting closer and closer to 0. We're not really worried about this part yet. Okay? And over here, it was getting closer and closer to positive infinity, so it was doing this. And again, this part I'm not as worried about um, at this point. So I hope that you can see this. We've talked about this before. Okay, you have done these before, but this is the line that it won't ever cross because 0 is not in my domain. And look what's happening to it. Okay, let's go look at the second problem. Second problem, given f of x equals 5 minus 2x over x minus 4. Again, find the value where f of x is undefined. And remember, it's undefined when my denominator is 0. Okay, so I'm setting my denominator equal to 0 to find that. X minus 4 equals 0, so x equals 4. X cannot be 4, so it's the value where it's undefined is 4. Okay, and we state that domain, lunch bell. We state the domain, we start at negative infinity all the way to 4. Close your parentheses, union 4 to infinity. So that's our domain. Now, where that value was undefined, we're trying to figure out what's happening to our graph at that point. So we're going to look at x less than 4 and x greater than 4. And remember that we talked about this is the left side of 4 and this is the right side of 4. So I'm going to pause, but before you do, you're going to go in and put 3.5 into each value for x. And if you have a scientific calculator that does not have a horizontal fraction bar on it, then it is really important when you put these into your calculator to put parentheses to start and stop your numerator and another set of parentheses to start and stop your denominator. So you have to tell the calculator all of this is in my numerator divided by all of this is in my denominator. And you tell it that by using the parentheses. So pause for a second, go fill out the chart, and I'm going to pause and the numbers will be there when I come back. Okay, we're back. I hope your chart looks like that. And if it doesn't, and if you have any trouble, please come see me because I think it's important for you to know how to use that calculator. Okay, so part B says if x is less than 4 as x approaches 4, so which of these numbers are getting closer to 4? 3.999. So as I go down, what value does f of x appear to be approaching? Well, I hope that you can see that those numbers are getting really, really large, and there is no set pattern except for they keep getting larger. So we have, that doesn't look like an infinity, positive infinity. And when I'm on the right side, when x is greater than 4, then those are going to negative infinity. Okay, now let's go find the x and y-intercepts. So remember, x-intercept means y equals 0 or my numerator equals 0. So what's my numerator? Is 5 minus 2x equals 0. I'm going to add 2x to both sides because I like to get rid of those negatives. And then, of course, we divide by 2, and x equals 5 halves. We don't leave our answer like that because that's the equation of a line. An x-intercept, excuse me, is a point. So this would be 5 halves, comma, 0. Now the next one, what's my y-intercept? My y-intercept means I'm going to set x equal to 0. And let me show you, this is kind of the fun part because you just get to go ignore anything that has an x in it in your equation. So what's left? 5 over negative 4. So when x is 0, y is 5 over negative 4 or negative 5 over 4. Same thing, just one negative in there. And so these are my intercepts. And now we're going to go graph these intercepts. So when we graph them, let's go with, um, just real quickly, what do we have? All right, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Good enough. Okay, so I have the point 5 halves 0, which is between 2 and 3. And I have the point 0, negative 5 fourths, which is just below negative 1. And the other really important number that we are talking about is that point where it's undefined. So if I go 1, 2, 3, 4, I think y'all figured out that we are looking at what we call vertical asymptotes. Okay, so from the left side, okay, this is the left side of 4. What am I approaching? What are my points going to? They're going to positive infinity. So I know when I connect these that I'm going to go like this to go towards positive infinity. Okay, on the right side, it's going to negative infinity. So I know that I have to, and I already have an x-intercept right here, so I also know I'm not going to cross that. So basically, again, we're just sketching. We're going to get into more detail after the next lesson. So that's what I want you to have, just a sketch on your graph. Okay, let's look at this last thing just to compare these two and help you understand what this question is asking and how I want you to answer it. So it says, compare the graphs for problems 1 and 2 near the vertical asymptote. So let's go back here. This is what we're looking at. We're looking at near that vertical asymptote of each function. Explain the behavior of each function as x approaches the value of x where the function is undefined. And I hope you realize that this point of where it's undefined is near that vertical asymptote. That I didn't know what that word was coming out. Okay, so we have problem number 1 and we have problem number 2 that they've asked us about. And I guess I should have made one for what's the vertical asymptote. So if you remember back in problem 1, if you want to go back and look at that, problem 1, where was our vertical asymptote? Okay, it's right here at x equals 0 because that was that point where our function was undefined. So we have x equals 0. And then here, our vertical asymptote was x equals 4. And what I want you to do is basically fill in this chart when we're talking about approaching our vertical asymptote from the left and our vertical asymptote from the right. Okay, so um, all I did in class was answer number 2 because it's right here, but I want you to go fill in number 1. But number 2 says, okay, from the left. So this is my asymptote. What is my function? My function is f of x. And what is it approaching? This is how we write mathematically approaching. So f of x, my function, as I get closer and closer to 4, I hope you can see that that is going to infinity. And what is f of x doing when I come from the right side? When I come from the right side, it's going to negative infinity. So that's what we did together in class. Fill that in with yourself, by yourself, and come back with your groups or individually if you want to, and check with your groups when you come back to class and let me know if you have any questions. Thank you. Have a great day.